All right, so how do we handle this? Well, we would simply say 5 times 5 is 25, and then the a just sort of hangs around, and that's it. Now, we can actually combine the 5 and the 5a because it's multiplication. If it was addition or subtraction, we wouldn't be able to go any further than that. And that would be it. So this one would be 9a. And this one would be 12y. Now we'll do the same thing again, except now we've got a couple different variables, and that's cool. So we've got 7 times 2 times 2, and that gives us 28. Then we've got y to the first times y to the seventh. The bases are the same, so I add the exponents. 1 plus 7 is 8. And then I've got v to the seventh times v to the ninth. The base is the same, so I'll add the exponent. 7 plus 9 is 16. That's how it's done. Now on this one, well, we got some addition or subtraction and addition going on, so I got to be a little more careful. So all of that is being multiplied by 6a squared. So you can think of it as, all right, there's one boy and there are 3 girls, and every boy dances with every girl, or every girl dances with every boy. Same thing. So 6a squared times 7a to the fourth is 6 times 7 is 42, and a to the fourth times a to the second is a to the sixth. Then 6a squared times negative 9a to the fifth would give us negative 54, and then a to the fifth times a to the second would be a to the seventh. Then 6a squared times 3 is just going to be 18a squared. Now we do the exact same thing again, except more variables, big deal. Okay, so this guy is going to get multiplied by all 3 of these. So we do the first one. Negative 7 times 9 is negative 63. And a w, and then x to the fifth times x to the second is x to the seventh. Then we'll do the next one. Negative 42, negative 7 times 6. And then w to the first times w to the third is w to the fourth, with an extra x to the fifth hanging around. Then multiply that. Negative 7 times negative 5 is plus 35. And wx to the fifth is it. There's no extra variables. So done the same way as the last, but now there's just another variable. Not a big deal. Now on this one, once again, we, every boy dances with every girl. We've got 2 boys and 2 girls. So 4x times x is 4x squared. And 4x times minus 8 is negative 32x. And then, so the first boy, 4x, he's done dancing with both girls. Okay, so we're done with him. Move on to the other boy, negative 1. So negative 1 times x is going to be negative x. All right. And then negative 1 times negative 8 is positive 8. And now we combine like terms if we can. And on these, usually the middle 2 or 2 of them can be combined. So we'll combine those to get minus 33x's. That's how we do it. Now we do it again, but with another variable. Big deal. Okay, a times 4a is 4a squared. A times negative b is minus ab, or minus ba, doesn't matter. Tradition says put them in alphabetical order, but it doesn't matter. Multiply those 2, we get plus 20 ab. And these 2, we get minus 5b squared. Once again, we've got some like terms here, so we'll put them together. So we got minus 1ab plus 20 more ab's, like negative 1 apple banana plus 20 apple bananas, which makes perfect sense. That's 19 apple bananas, or ABs. And then 5 minus 5b squared, that doesn't change. Just gotta love those apple bananas. Okay, same thing as before. The only difference is now we got parentheses, and here's the really popular wrong way of doing it. A lot of people say, hey, that's 5y squared minus 2v squared. Okay, and that's wrong. It's, it's close, but it's wrong. Even worse, some people will leave off the parentheses and not square out the 5 and the 2, just the y and the v. So that's not good. Bear in mind, what that squaring means is 5y minus 2v times itself. 5y minus 2v. 2 boys, 2 girls. Every boy dances with every girl. Now, there is a shortcut for doing these that Alex is hoping that you'll do, and it's really not a big deal. But, whatever. So, but I guess I'll do it. So the shortcut is you're going to get the first term squared, and you're going to get the last term squared, and that's what I had originally. But what most people leave out is plus 2 times the first thing being squared times the second thing being squared. So we get 25y squared minus 20y v plus 4v squared. And so this middle thing is what they leave out. And most people say, whoa, where'd the 2 come from? Well, when you multiply this out the long way, you're going to get negative 2v times 5y, and you're going to get it again. You're going to have 2 of them. So that's where the 2 comes from. I'm getting really hungry for an apple banana. Okay, so on this one, we've got 3 boys, 3 girls. Every boy dances with every girl. It's the same thing, except now it just takes a little longer. Okay, so x squared times 3x squared is going to be 3x to the 4th. And then minus 4x cubed. And then plus 2x squared. Okay. And I can just keep going on one big long line of these, and that's fine. That's usually what I do. But I'm going to show you a little something different that you can do if you want to, but you don't have to. Right. Second, a lot of people do it, but certainly not everybody. So 6x times, so the second boy is now dancing. 6x times that is going to give us 18x cubed, and I'm going to put it right there underneath the other x cubed. That way I'm lining up vertically the like terms. Maybe you like it, maybe you don't. All right, 6x times minus 4x, that's going to be minus 24x squared, and then plus 12x. Okay. Now, the last boy dances. 18x squared, lining them up, minus 24x. Oh, there's a lot of that going around. And then plus 12. So I add it all up, combine like terms. So that guy has nobody to hook up with. How sad. These 2 are like terms. And I've got negative 4 and 18. That's going to leave me positive 14 of them x cubes. And then these guys, I've got, give me negative 4x squareds. These guys, I think, let's see. Yeah, that looks pretty good. And then those 2 would be negative 12 x's. And then this guy is alone, so just plus 12. Yeah, they take a few moments, but it's cool. And of course, on all of these, you're going to plug in the original. You're going to plug in the final into your calculator to see if they match. And we should probably just do that right now, huh? So the idea here is that the original expression and our final expression are equal to each other. So we are going to plug them both in, see if they match. And this is something you should be doing all the time. All right, so the original expression, x squared plus 6x plus 6 with parentheses. And then 3, -4, and 2. I'm just looking at the coefficients. Okay, so there's the original expression, and supposedly that's equivalent to what we got. So plus 14x to the third, I think. Yeah. Minus 4x squared plus 12. And you will get good at this. You will get fast. Okay, so if I go to the table, if they are equivalent, the 1 in y1 and the 1 in y2 are going to yield the same results no matter what I plug in for x. And I don't care what's in the x column. I just care, do the y1s and the y2s match? Yes, they do. Therefore, I have made 0 mistakes.